Hello all, welcome to CloudForce Training Institute. Today we are going to discuss about EBS volumes. In this session, we will learn what is EBS, why EBS is required, how to attach the EBS volumes to the server, how it works, what are the life cycles of EBS value, and what is snapshot, what is the difference between snapshot and EBS value, and how to resize the EBS value, how to mount the additional EBS volumes to the server. These are we are going to discuss in this session. EBS Volume is a storage service that provides the storage to your instance. Consider your laptop is a EC2 instance and hard disk, whether it is SSD or HDD, whatever, consider that is a EBS volume like C drive. Okay, and operating system, whatever it is, like Windows, Linux, or Mac, anything. So if you restart your laptop, the file stay in your laptop because those are stored in hard disk. Similarly, if you restart EC2 machine, the file should remain same. So for this, we have to use EBS volumes. If you see how EBS volumes works, so this is a consider. This is a EC2 instance. These are the EBS volume. You can attach multiple volumes to the EC2 machine. Why we are using this EBS volume? To store OS files, application data, user data, and logs, and many other files which required. So any data we can store in EBS volumes. So when it comes to why EBS value, the server does not only require CPU and RAM, right? It also required storage. Same kind of our laptops to store our data. That might be operating system, OS, application data, user data, and any other logs related to application. Those we will store in EBS. There are two types of storages are available. One is permanent storage, another one is instance storage, nothing but temporary storage, or you can also call ephemeral storage. So using the EBS value, we can persist in the data. But if you use any ephemeral storage, we will lose the data post reboot of your server. But if you use any EBS value, you can retain the data. Post termination of server, nothing but EC2 machine, we can save the data unless before you are terminating the EC2 machine, you can detach the EBS value. So that same EBS value we can attach to any new servers. But if you use any ephemeral storage devices, you will lose the data permanently. So we can attach and detach to the EC2 machine. We cannot detach the EC2 machine if you use any ephemeral storage devices. So snapshots are also supported in AWS EBS volumes, but ephemeral storage devices, it will not support the snapshot. Snapshot is nothing but the EBS volume backups at particular moment. Okay, this is the performance is high, and this is also performance is very high. This is small difference between permanent storage and instance storage. So how EBS works, you know guys already. So you have to attach the EBS value once you create it. So you have to attach to the EC2 instance. So once it is attached, you are able to access the EBS value. Then you can copy the data. There are two types of EBS volumes, nothing but root devices and additional volumes. Means root device is nothing but when you are creating any EC2 machine, it will create by default. Okay, and additional volumes means we have to create the EBS values and attach to the EC2 instance. Now let's see practically how it is. You can see my existing server. Go to the storage. Here you can see one volume is attached to the server. You can see slash dev slash sda1 is the one, that is the root device name. So without root device, we cannot log in into the server. Do you want to try that one? Let's see. I am selecting another server. Go to the storage. Click here. Copy this one. Select this one. You have to detach the volume. Before detach the volume, you have to stop the server. Now go to the server. You can also get here. Go to the server. Select this one. Stop the instance. Let it stop. My server is stopped. Going to storage and click on the value. Select this one. Just refresh. Detach the value. Refresh it. So earlier it is in used. Now it is in available state. Go to the instances. Cloud one. This is stopped, right? Just refreshing the page. You can see there is no storage devices. Now I'm starting the instance. You can see it is failed to start the instance because instance does not have the volume attached at the root. That means slash dev slash sda1, because all the OS related information will store in the root device. So if you don't have those configuration details, you cannot able to log in into the server. Okay, I'm terminating the server because I'm not using anymore this one. So I'm deleting. So I have only one server now. So we can use that one. Now we will create the new EBS volumes and we will attach to the existing server. Okay, come to the EC2 dashboard and click on the EBS volumes. Create here. Click on the create volume. We will see one by one. Volume types, size, IOPS, everything we will see one by one. As of now, I am creating with some 12 GB of data. Sorry guys, I'm creating one more value. Before going to create, we need to consider one key thing, the availability zone. For example, my server where I have launched in AP South 1A. So the EBS value which you need to attach, right? That one also you have to create in same availability zone. Then only you are able to attach the EBS values to the instance. So I'm selecting 1A only. I'm creating one more 100. Selecting 15 GB. Let me delete the available one, otherwise I will get the charge. Which one? This is 10 GB one. Let's refresh once. So I require this one need to delete and this one need to delete. This is first one is for old server one. I'm deleting these values and confirming. I'm deleted. So I have only one existing EBS value, that is for root device, and another one is which I created now. Now select this one means which is available, that one you have to select. Go to attach the value. Now select the EC2 instance. You can see test EC2 instance is, and you can see the instance ID also 585C9C. You can confirm with the instance ID. So device name. So slash dev slash SDA1 is the root device which is already in use. Now I'm selecting slash dev slash SDB. So now we will log in into the server. I have logged into the server. I am giving df-h command. So these are the devices. You can see 3 GB. I mean, these are the devices is available. These are all the root devices slash dev slash nvme 0 n1 p3 like this. So size is 9.8. So that is a root device we have taken like 10 GB. So in around 9.8 GB we have used around 3 GB. So available is 6.9. So used percentage 31. So root device always mounted as a slash. We will see what is mount point everything. But I have added 15 GB of data. I don't see anything here, anywhere here. Okay, to see that you have to execute lsblk is the command. You can see, right? It is able to see. So once you mounted this 15 GB one, then only you are able to access this 15 GB EBS value. Now come to EBS dashboard. Both are in use. For going to mount the additional value, we will see what are the information available in the root device. So root device always mounted as a slash, nothing but the root directory. It's a top level directory. Go to root directory. You can see slash. Now ls I'm giving. So these are the some mount points available here. So we will see one by one what are these. So first thing, cd slash. So this is the top level directory. It is a parent directory for the all other directories. It is also called as a root directory. It represents as a forward slash. Here cd slash. So it will, you can go to the root directory. Okay. So under this we have multiple mount points. So here we have cd slash root. We will see one by one. cd slash root. It's a permission denied. Let me log in into the sudo. Okay. I'm going to cd root. cd root is the home directory for the root user. Nothing but the super user. It provides the working environment for the root user. Let's see, any files are created by default. Some files are created here. Okay. Means I have used this. So with the root user. So I have created, these are the files with the root user and cd home, cd slash home. It is a home directory for the other users, nothing but the local users. You can see what are the users we have created. EC2-user and Shiva is the user we have already. So for them, while creating these users, it automatically creates the home directory for them. If you create any new user, it will also create. You can see here user and cloud-1. I'm sorry, user and cloud-1 is the username. Now I'm giving ls-l in the home directory. You can see cloud-1 is created for the local user. Now we will see boot. So it contains the bootable files for the Linux server. Some, if you want to reboot the server, those information, it will be stored in the boot directory. You can see in the grub2. You can see here grub.config file. Boot information you can see here. This is the some information related to boot. Now we will see cd/etc/etc. So it contains all configuration files. You can see here. So SSH, SSD, SC Linux, RPMs. These are the pre-installed softwares. Those configuration files are already stored in /etc/password. You can also see we have installed the Datadog in last classes and some other like HTTP also. We can also see those configuration files in the /etc/etc Datadog-agent. You can see the configuration file here. Datadog.yaml is the configuration file for the Datadog. Like this, configuration file for the any service will store under /etc. Now, ESR. By default, softwares are installed in ESR directory. There is some information in ESR/bin. Let's go to /bin. What are the available? So these are the some bin files for the existing or predefined softwares. So by default, softwares are installed in ESR directory. So now we'll see /opt. It is optional directory for the /ESR. So it contains third-party softwares. You can see Datadog-agent is we have installed, so that is present in the /opt because this we have installed it. So that's why it is stored in /opt directory. So there is one more file, a bin. So it contains commands used by the all users, and we have also sbin. It contains the commands used by the only super user. And we have /dev also. So it contains device related files like /dev slash you can see right /dev nvme. So this type of file system information it stores in the /dev. And we have proc also. It is very important one. So it contains the process related files. So content is here. The content is not permanent. They keep changing the values because that's why it is called as a virtual directory as well. Because file contains useful information, it will change. So you can also see the memory information, CPU related information in proc. Okay. Here you can see CPU info, mem info. So how much CPU is using the current system and how much memory is utilized. So those we can see from the proc directory. We have also MNT folder. So here the default mount points for any partition it will store here. And media we have, where is this? Yeah, media. So it contains all removable media like CD-ROM, pen drive, those type of information is available here. We have library files also. So here it will store the library files which are used by the OS. So these are the primary information used in the root directory. This is the root directory we have attached to the server as /dev/sda1, and this is the additional one. but additional one we have not able to use in the server because we have just added to the server, but you have to mount it. Before going to mount the additional volume in the server, you should know what is file system. So file system, it is the method of storing the data in organized format. So you can store the data like it might be files, images, videos, whatever. Okay, so it is a method of storing the data. Nothing but you can say directory also file system. In the C drive, if you see, you have multiple directories. You can also call it as a file system. So what are the different types of available in the different types of file system available in the Linux? So we have ext2, ext3, ext4, xfs. ext2 and ext3 are outdated. Currently, ext4 and xfs is the new trend. So these vfat, cdfs, these are related to Windows machines. So ext4 mostly nobody is using now. So xfs is the current trend one. Okay. So based on the performance, we have to select the ext4 or exfs. So before that, you have to know what is mounting. Before mount, we have to know what is mounting. In order to access the files, for example, in the C drive, I need to access the some files. Okay, some files. Like I'm going to inside the users directory. So because means I'm able to access in the server also. I can go to root directory. I can go to /dev directory. I can go to slash ESR 1000. I can do any operation here because these are all mounted. So in order to access the files or file system, we have to mount it. So you can see here attaching a directory to the file system in order to access the partition, and it's a file system known as a mounting. So there are two types of mounting in the Linux. One is temporary mounting, another one is permanent mounting. So in the temporary mounting, we have to use this command mount and options, device name and directory name. And there is a disadvantage of temporary mounting. So once you mounted temporarily post tribute of your server, those mount point will gone. But if you use permanent mounting in the /etc/fs tab, so there we have to enter the some values related to mount information or device information. Then post tribute also the data will be present in the particular mount point. We will see those also, the difference between temporary mounting and permanent mounting. So come to the server, lsblk is the command to list the blocks, means devices. You can see here NVMe01. Okay, the size of the device 10 GB. These are the partition under these. We will also see LVM partitions. So NVMe 1N1 is the additional block storage which we attached with 15 GB. Okay, these are mounted as a part of slash. Okay, means slash is nothing but root device. Now we will mount the additional device as well. So once you attach the new value to the server, we have to log into the server and see whether it is reflecting or not. We have to use lsblk command. So before you have to create the or mount the existing, additional volume, you have to create the one file system. So this is a Linux concept, guys. So to create the file system, you have to use this command mkfs, make file system. Okay. If you want to create ext4 version, you have to use ext4. Otherwise, you have to use xfs. Okay. /t is the command. xfs /dev. Every mount information stored in /dev. Okay. Now you have to give the device information NVMe 1N1. Now the additional EBS volume in the server. So the advantages of mounting, we can able to access the particular directory. Okay. So to mount it, we have to create the first file system. mkfs make file system. Then .xfs. xfs is the file system type. /dev and this one device name NVMe1N1. Okay, enter. You can see this is a output, you got it. So file system is created. Now we have to create the directory. Let's suppose I'm taking the /data as a directory. Now I'm going to mount this one. Okay, to mount it, we have a command mount NVMe 1N1 NVMe 1N1 then directory name /data. Okay, now if you see df-h, you can see /data. Now I can do the operations like cd. I can go to the /data. I can do any operation on this, like creating the files, creating the directories, so like this I can do the any operation inside the files directory. Okay, this is the main advantage of the mounting. As said, we have two types of mounting options. One is temporary and another one is permanent one. So temporary mount points will store in mtab /etc/mtab. You can see here cat /etc mtab /dev /nvme1n1 device name and /data. It is there in the mtab file. To make it permanent, we have to give the entries in the fs tab. So the disadvantage of temporary mounting, after rebooting your server, the mount point will be gone. So your data will also be lost. So to make it permanent, we have to give the entries in the fs tab. To make entries in the fs tab, there is some scenarios, like we have to enter some values like device name, mount point, file system type, mount option, and this one defaults we have. I'll show you in now, and this I will show you. Okay, instead of device name, sometimes what will happen is sometimes there will be a mismatch error. So to avoid this, instead of device names, we are going to take the UUID values. So every device have the UUID, unique one. Okay, so to get it, we have a command to get it. plk id /dev nvme 1 and 1. So this is the UUID. Let me copy to the notepad. Now open the fstab entries. For this, the command is vi/etc fstab. We are opening the fstab file. Now we have to enter the values of the particular device. So instead of device name, we are giving the UUID and mount point. Next option is mount point. So on which mount point we have used /data is the mount point. And then file system type, we have taken XFS. Then defaults and 00. So now what are these 0 and 0? When it comes to first 01, first option, whether you can keep 0 or 1. So 0 means it will not take the backup during the reboot of your system, and 1 means it will take the backup using dump command. Okay, and for the second 0 you can keep 0, 1 or 2. So what are those means? 0 means it will not check the file system during the reboot of your system. If you keep 1 instead of 0, it will check the root file system first, then it will check the file system. If you keep the 2, first it will check the other file systems, then it will check the root file system. So if you keep 1 other than the 0, the reboot time will take more time because it needs to check the file system and it needs to check the backups. Okay, it will take some time. So I'm saving the file. To save the file, we have to use :wq exclamatory mark. Enter. You can see the cat fstab entries. You can see the details here. Okay, UUID, the device UUID, and mount point, and file system type, defaults 0 and 0. Okay, so this is how we are mounting permanently. Even though system is rebooted, the /data will be remain same. Means it will exist. So data we will not be lost. So now we can see /data size is 15 GB. So after some time, there was a requirement. Consider we required we need to increase the size of this particular value. So how to do this? For example, we need a requirement to extend till 25 GB. So go to the server, storage, select the 15 GB one, select this value, go to the actions, modify the value, extend to 25. Okay, and modify. You can do it online, means you no need to stop the server to extend the value. Now go to the server. Now see dff-h. You can see still it is 15 GB only. Even if you give the lsblk, you will get some details, like here it is showing 25, but here showing 15 GB. So lsblk shows the block device size. It reads the device size from the operating system. dff-h shows the file system size. The file system has not been expanded yet. Now we have to format it. To format it, there is a command. Since we are using the XFS file system, there is a command XFS growfs /data. You need to give the device name. Okay. change it from, you can see here, data blocks change it from some GB to some other bytes. Sorry, not in GB, it's in bytes. Now you can see dff it is showing 25. So like this, we can extend the additional values when it is required. Hello, welcome to CloudForge Training Institute. Today we will discuss about logical value management in using EBS volumes. What is logical value management? In short, it is also called as LVM. So, logical value management is a storage management technology that allows to combine one or more physical values into one single disk, and we are assigning those storage to the multiple mount points. In the previous session, we have added 15 GB of additional value to the server, and we have extended to 25 GB and mounted as slash data. But in the real-time environments, we usually don't rely on the one large disk. Instead, we attach multiple EBS volumes and combining them using LVM technology. Means I will take the multiple EBS volumes and I will combine them, and I will utilize this space to multiple mount points. If you see this diagram, you will understand easily. So consider slash dev slash SDA1 is one EBS volume with 100 GB, and this is 150 GB one is another EBS volume, and 200 GB is another EBS volume, and slash dev slash SDD1 means 50 GB one is another EBS volume. So total I have 4 EBS volumes. Okay, so consider, calculate this one, 100 GB plus 150 GB plus 200 GB plus 50 GB, total 500 GB. So I will combine them. Okay, I will combine them. Total, if you see here, 500 GB. And from this 500 GB, I'm allocating the spaces to different mount points. If you see, I'm allocating 50 GB to the root device, and 250 GB to home path. Okay, home mount point, and 100 GB to slash var, and 10 GB to swap memory. So remaining 90 GB is free space. So whenever there is a requirement to extend the particular mount point, like a slash home or slash var, I need to increase to another 10 GB or 20 GB. So I can utilize this free space. So like these LVMs are very useful. There is another advantage using the LVM. If you don't use the LVM, you have to use separate EBS volume for each mount point. Consider slash data is a one mount point. So instead of 25 GB, consider this is a 100 GB. But you are not utilizing the 100 GB. Okay, so you are using only 25 GB and you are not utilizing the remaining 75 GB, but you have to pay for total 100 GB. So instead of that, I will use some amount of, using the LVM, I will create the multiple EBS volumes and I will make them into one group, like earlier as I shown in the diagram, and I will utilize the space from there to the multiple mount points. Hence, we can also save as part of cost. So we will implement the LVM practically now. Before going to implement the LVMs practically, you should know about components of the LVM. Those are physical volume, volume groups, logical volume. So what is physical volume? It stands for PV. So it is a standard partition. In simple terms, if you want to know, nothing but the EBS volume. Okay, so PV is nothing but the EBS volume. It's a physical device. So volume group, nothing but multiple, like 2 or more physical volumes or EBS volumes we are combining together and making as a one group, that is called as a volume group. and then logical volume. So logical volume is a virtual disk that is created from the volume groups. So applications and users don't use physical volumes, means EBS volume, EBS disks directly. They use logical volumes. Means it behaves like a normal disk, and you can format it, you can mount it and store the data on it. Now, to avoid the confusion with the slash data, I'm creating new server in Northern Virginia region. I have created already. I'm creating two more physical volumes, nothing but the EBS volumes, and attaching to the existing server. Before that, let me check where my EC2 instance is launched, means which EBS volume, which availability zone. It is ESIST 1D. So we have to create the EBS volumes in ESIST 1D. Go to the EBS volumes, create now. Refresh the page. Okay, I have one server. I have one EBS volume only. So go to the EBS volume session and create volume with 15 GB. I'm creating one EBS volume in ESIS 1D. I'm creating it and creating one more EBS volume with another 15 GB. So total 30 GB in 1D only. I'm created. Both our volume should be come to available state. Yeah, both are came to available state. I'm attaching to the existing server. Attach. Select the instance. Device name. /dev/sdb. And I'm attaching one more EBS value to the existing server. /dev/sdc. Attach the value. Now let's see, both are attached to the instance. And now logging into the server. Logged into the server. Switching to root user. LSBLK. You can see the root device already mounted as a root, and I have created two volumes, right? So one is 15 GB, another one is also 15 GB. Those device names are NVMe 1N1, another one is 2N1. We have created the two EBS volumes and attached to the servers. That means we have created the physical volumes, two physical volumes. Now we will create the PV, means physical volumes. We have to combine them. So for that, we have to use the command pv create. Go to the server. Pv create is the command. /dev/nvme 1N1 and /dev NVMe 2N1. So physical volume is successfully created. Okay, so these devices, creating the devices file like this. The information stores here. Okay, so physical volumes are created for the both the devices. You can verify whether PVS is created or not. Physical volumes are created or not. PVS is the command or PV display is the command. You can see here some information you will get related to physical volumes. PVS. This is the information. You can see NVMe size 15 GB and size is 15 GB, and or also you can use PV display also. Some more information here. PV name you are getting, VG name, because I have not yet created, that's why it is not showing it. Okay, and size and how much it is allocated, everything it is showing. You will get more information if you use PV display. Now we have to create the volume groups. Okay, means we are combining them. Okay, like this. If you see, we are combining them. The total 500 GB one we are combining as a volume group. So for this command is vg create vg data or anything vg app, anything you can create for our namesake only. Okay, these are the devices. This is name for the value group. Any name you can give. Okay, vg create vg data means vg create is the command and vg data is the volume group name. And now we have to give the device name. You can see here /dev nvme 1n1 and 2n1. 1n1 and /dev nvme 2n1. Volume group vg data successfully created. You can verify using vgs command or else vg display also. You can see it's showing 30 GB around. Okay, 29.99 means PV display. We have created two EBS values with the 15 GB each. Okay, means 30 GB total. Here it is showing, right? Easy data. If you see here, 500 GB we have taken with the different values and we have combined. So make them into 500 GB. Same kind of, we have taken two 15 GB EBS values and combined them. So we got around 30 GB. Okay, easy display or VGS is the command. Here you can see VG name, VG data, format LVM. This is some information you are getting here. Now we have to create the logical volume. This is the actual device which we can operate. We can do anything. So create a logical value, name, LV data, any name you can give. So this is your actual device. You can do any operations on it. Okay. So there are two types of commands for this. Means LV create -l 100% free -n LV data VG data. Means LV create is the command -l, okay, length, okay, 100% free means you have to use this 30 GB to the only one mount point. Only one mount point you can use the 100 GB. 100%. Okay. -n means name, LV data, LVM name, VZ data means here we have used it, right, while creating the VZ group, means volume group. So that name, whatever the name you have given here, means volume group, you have to give here. Alternatively, you can also create the logical value by specifying the size. Okay, if you required the LVM size with 15 GB or 18 GB, 20 GB, you can give 15 GB also. Okay, now let's create with LV create with size. Okay, the command is LV create -l. I'm creating with 17 GB, 17G. Another now LV name, LV data, logical value name. You can give any name and VZ data. Whatever the name you have provided to volume group, you have to give here. Let's enter. So volume group is created. LV data is not found. Sorry, I have not mentioned the -n. So LV create -l 17G size. Name I have to give it, right? -n I have not provided. LV data, you can give any name. VG data, whatever the name you have given to volume group, that you have to enter here. Now I'm entering. Okay, logical volume data is created. You can see LVS is the command. So LVS is created. Okay, LV display also there is another command. So because here it's showing 17 GB because I have created with 17 GB LV display. You can see LV path slash dev slash BG data BG data LV data. LV name is LV data and value group name is BG data. Okay, and LV size is 17 GB. Now see LSBLK. Okay, LVMs are created. If you see here, okay, if you see here, BZ data. I mean, this is the name for the value, logical volumes. Okay, total 17 GB I have created with 17 GB. Okay. Now I'm utilizing the this 17 GB from the total 30 GB. I'm utilizing the 17 GB for one mount point called as a app/app something. So to mount the any particular directory, we have to create the some file system. So now we have to create the file system on these LVMs. So this is the command you can see nkfs.xfs. XFS is the file system type, and this one /dev bz data and lv data. Okay, this is the lv name. Okay, same thing I'm giving here. nkfs means make file system. XFS is a file system type. You can see another /dev slash vg data slash lv data. I'm creating the file system now. I have created the file system. Now I have to create the directory which I need to mount. I'm using /app. Before that, let's see what are the mount points available in my server. So these are the available mount points. So I'm using now as a /app. Okay. mkdir make directory /app. This is the command you can see here. mkdir /app. Okay. So it's not it mounted. Okay. Now we have to mount the logical value. To mount it, so mount is the command device name and directory name. So device name is /dev /bg name bg data and lv name means total path of the logical value lv data /app. Now see the 70 GB is assigned to /app. Okay, so we have mounted the /app on LVMs. You can also give the fs tab interest to make it permanent mount. That we can do as per our exercise. So we have created the /app mount point on LVM with size of 17 GB. But we have created the volume group with 30 GB. You can see the volume group size is 30 GB and free is 13 GB, 13. So because 17 GB we have attached it to, utilize it for the /app. Okay, so now I will create the another mount point from the same logical value with some amount of space. Okay, to create another mount point, we have to create another logical value from the same volume group. Like we have to create another volume group. Sorry, another logical value. So LV create -L. So I have 13 GB of free space. From this, I will utilize 5 GB. Okay, -n. So name will be different now. Okay, because we are creating the new logical value for the new mount point. Okay, so I will take some like NV logs. And from the same volume group we are creating. So what is our volume group name? BG data. Give enter. Invalid argument. Sorry guys, it's capital L. And these are the small typo errors we do commonly. Okay, so LV logs are created. You can see LVS. Okay, so we can see two logical volumes we have created. One is with 17 GB and one is with 5 GB. Now we will create one mount point. To create the mount point, first we have to create the file system. mkfs dot xfs /dev, and what is the volume group name? This one. Okay. You are not able to find the logical value name, you can find using LV display. Here you can see this is the LV path for LV logs. Okay, now we can create the file system. mkfs dot xfs /dev /vg data /lv logs. So one file system is created. Now we have to create the mount point, means directory. mkdir /logs I will created, and then now we need to mount it. Mount /dev /vg data LV logs, right? This is the LV name. Now directory name /logs. You can see now logs are created with the 5 GB. Okay, you can see VGS or VG display. You will come to know total allocated size and free size. Now you can see here LSBLK mounted with /app /logs with two different logical volumes. Okay. So using the logical volume, we have created /app and /logs. Okay, with 17 GB and 5 GB. Total 22 GB. But still we have 8 GB free space. So consider /app is getting filled. Okay, just assume /app is getting filled. We need to extend the size. Okay, we have 8 GB free space. So we can allocate some space to /app from the free space. Okay, let's see how it is. So there is a simple command. We can extend the logical volumes. So let's see. LV extend -L plus how much GB you want to add to the particular mount. Okay, so I have 8 GB free space. I am adding 4 GB. And what is the logical value name for this one? /dev /vg data and LV data. This is the name. Okay, the size of the logical volume is modified from 17 GB to 21 GB. Okay, but if you see here /app, still it is showing 17 GB. Okay, so if you want to update these modifications, you need to run the one more command. Since we are using the XFS file system, we have to use this command XFS growfs, okay, /app. Okay, the data blocks change it from some bytes to some bytes. Okay, now let's see df-h/app. You can see now 21 GB. Okay, it is modified to 21 GB. Now you can give VGS. Still 4 GB is free space. Now you can give lsblk. Okay, /logs. I have 5 GB. Now I'm going to extend /logs as well. Okay, to do that, lv extend is the command -l. Okay, plus just 2 GB I will add. Okay, /dev / what is the lv name, vg data, and lv logs. So it is changed from 5 GB to 7 GB, but still if you see df-h /logs, the changes will not be replicated unless you execute this command xfs growfs /logs. So you can see now change it from some bytes to another bytes. You can give now df-h /app is changed to 21 GB and logs and /logs is changed to 7 GB. You can see the VGS 2 GB is still pending. Okay, if required in the future, we can add it. Okay, so instead of creating the multiple EBS values to the particular mount point, we can combine the multiple EBS values and make it as one volume group, and we can divide these some spaces to the particular mounts. So number of mount points we can create and we allocate the space from the PG volumes. Okay, so this is the biggest advantage using the LVMs. Instead of using multiple EBS volumes, we are creating the LVMs. Thank you guys. If you really like this video, please subscribe. Thank you so much. See you in the next session. Welcome to CloudForce Training Institute. In this session, we will discuss about what are the types of EBS volumes available in the AWS account, and what is snapshots, how to create the EBS values from the snapshot, and how to detach the EBS values from the EC2 instance, and other topics we will see. Amazon offers different types of EBS values based on performance and workloads. So they are mostly classified into SSD and HDD volumes. Whenever you are planning to buy external hard drives, you are looking for the SSD and HDD. When compared to SSD, HDD performance is very low. So mostly we choose SSD hard disks. In AWS also, based on the performance, it provides different types of EBS volumes. Those are GB3, GB2, IO1, IO2, cold HDD SC1, and ST1, and magnetic. So these are based on the performance. Performance means we need to calculate IOPS and throughput. IOPS means input output operations per second. Means how many read and write operations happening on particular device per second. Those we need to calculate. And throughput. Throughput is nothing but how much data is transferring per second. It measures in MB per second. So based on these two values, Amazon is providing different types of EBS volumes. Those are GP3, GP2, IO1, IO2, cold HDD SC1, ST1, and magnetic. Now let's see one by one. So first is GP3. It's a general purpose SSD type. Okay, so it is useful for the many workloads. Let's go to the AWS console. and see, create a value, general purpose SSD. Okay, so minimum size is, if you see here, minimum size is 1 GB and maximum size is 16 TB, and same thing I have mentioned here, 64 TB. And the baseline operations, IOPS, okay, input output operations per second, minimum is 3000 and max is 80,000. Okay, same throughput 125 MB per second. So minimum is 125 and maximum is 2000. Okay, so availability zone that you know. So based on this configuration, GP3 we can select based on the requirement. So if you see the use cases here, so it is useful for the web server related applications and application servers, development, test environment, and a small to medium related database. We can also store the database in this type of value groups, and boot related information we can store there, and general purpose workloads. So there are some advantage if you use the GP3. So lower cost than the GP2, better performance, predictable latency, and independent tuning of storage, IOPS, and throughput. We can change based on our requirement. Okay, so here if you see 3000, we can change the up to 8000, and here we have 125 Mbps, and we can change up to 2000. So we can change based on our requirement. But if you choose 3000, you will get some amount of cost. I mean, you have to pay some amount of cost. If you choose 4000, you have to pay some amount of cost. It will be vary based on IOPS ranges and throughput ranges. Another one is GP2. This is a general purpose SSD type. You can see. So it is designed for the balance of price and performance. Okay. So now AWS is recommended for GP3 for new deployments, because I heard GP2 is going to decommission very soon because it's a legacy one. So if you see the settings or options available for the GP2, the size is minimum is 1 GB and maximum is 64 TB. Okay, and IOPS 300, and throughput there is no that option. Okay, so this is the main disadvantage if you choose GP2. So that's why AWS is recommending GP3 instead of GP2. So some key features we can see. So most of the companies using GP3 instead of GP2. So existing workloads, legacy applications. It's also like same as GP3, but there is a options. If you see here, there is no options to choose our IOPS and throughput. Default one only we have to choose. So this is the main disadvantage if you use GP2. Let's see one by one. Let's see how to see some practical overview why GP2 can be expensive. Suppose your application needs storage of 100 GB and performance 3000 IOPS. Okay, with GP2, okay, 100 GB provides only 300 IOPS. If you see here, 300 only it is providing. Okay, so 3 IOPS per GB. Okay, so minimum of 100 IOPS means 3 IOPS per GB. Like this, 100 GB provides only 300 IOPS. Okay, to reach 3000 IOPS, we required around 1 TB storage. So if I choose the GP2, I need to choose 1 TB of EBS volume. So I need to pay for entire 1 TB. But if you choose the GP3 for storage 100 GB one, if I choose GP3 for 100 GB, it's already providing the 3000 IOPS. So I am paying for only 100 GB, not for 1 TB. So this is the main advantage if you use the GP3. That's why cost is very less when compared to GP2. Next is IO1. It's a provision IOPS SSD, not general purpose. Okay, it's a provision one. So this is mainly using for the high critical applications which requires high consistent predictable performance, low latency, those type of applications. Okay, Latency means within how many seconds we are reaching your application. Let's suppose from my laptop I am connecting to Google, ping google.com. I can connect google.com within 8 milliseconds, 9 milliseconds, and an average of 10 milliseconds I'm taking. The average 10 milliseconds. Within 10 milliseconds, I'm able to reach google.com, Google application. Same kind of, within how many milliseconds or seconds requests are able to reach your application. This is called latency. Okay, so those type of low latency applications we can use the IO1, but there is some disadvantages when compared to GP3. So if I choose IO1 provisioned IOPS SSD, here I can see minimum is 4 GB and max means 16 TB only. Okay, and IOPS if you see up to 50 IOPS per GB. Okay, so if I choose the 100, it's a maximum IOPS is 500 only. If I require more, I need to add extra. Okay, now I'm choosing the 1000. It is moving to 50,000 IOPS. So it provides only 50 IOPS per GB. This is the main disadvantage when we are using the IO1. Now another type is IO2. This is also next version of IOPS and provisioned IOPS SSD. This is also useful for the critical applications for high availability. So if you choose the IO2 here, it provides 1000 IOPS per GB, so which is high when compared to IO1. So this is the main advantage. Also, we can extend up to 64 TB, but IO1 provides only 16 TB, 16. But here 64 TB we can increase. But there is some disadvantage when you choose IO1 or IO2. There is no throughput. So by default, what application is providing or AWS is providing, that will only applicable. You can't change it. So this type of IO1 or IO2 related EBS volumes can be useful for the database related applications like SAP, HANA, Oracle database, Microsoft SQL servers. Kind of these type of database purposes, we can use these storages. So another disadvantages, if you choose IO2, it's high coster than GP3 and not suitable for the general purpose workloads. So we should use only when application require high performance and high availability. The next EBS type is called HDD. This is low cost EBS value. Okay? This is HDD, okay, hard disk drives instead of SSD. So you generally knows SSD performs very well rather than HDD. For example, if your laptop is HDD storage type, that performance is very low when compared to SSD type. Okay. So even if you see in the console called HDD, choose it. So minimum size is 125 GB and maximum is 16 TB only. IOPS, there is no IOPS. IOPS we can't choose. Okay, and throughput also very less, 6 MB per second. Okay. These are useful for backups related requirements. Okay, so if you want to store your backups or archive your data, so these type of EBS volumes are very useful. Okay, and advantages are very low cost when compared to other EBS volumes, and disadvantages high latency and poor performance. So these are not recommended for the root boot volumes for the EC2. The next one is throughput optimized HDD. This is also HDD EBS volume type. So this is designed for frequently accessed and throughput intensive workloads. So this is ideal for workloads that process large amount of data continuously. Okay, so provides a balance between performance and cost. If you see in the console, so-called HDD throughput optimized HDD. It provides minimum of 125 GB and maximum of 60 TB. So there is no IOPS when compared to cold HDD. Throughput optimized HDD has throughput of 20 Mbps. Some key features: HDD bucket storage and optimized for the high throughput like 20, right? 20 Mbps. So it is lower cost when compared to SSD volumes. So mainly advantage is a large data of to store the large amount of data. So disadvantages: high latency, low throughput. It cannot be used as a easy to root device. And the last one is magnetic one. It's a standard and oldest generation of EBS volume. It is also HDD based device. Okay, so it is useful for the small amount of data and infrequent access. Like if you don't want to access frequently your application or data, you can use this type of magnetic one. So this is also HDD, right? So we have high latency, low throughput, and cost is also very less. If you see in the console, magnetic standard, so maximum is 1 GB and minimum is 1 GB and maximum is 1 TB. There is no IOPS and there is no throughput. So as per my experience, we mostly use GP3 or IO2, okay, in real-time scenarios. But there is an advantage using IO1 and IO2. It is a multi-attach. Like we can attach the same EBS volume to multiple EC2 instances. Okay, so up to 16 instances we can attach. But if you choose the GP3, GP2, other than the IO1 and IO2, you cannot use the same EBS volume to multiple EC2 instance. So one EBS volume to one EC2 instance only. Okay, so it's like this. But if you choose the IO1 and IO2, the same EBS value can be attached to multiple EC2 instances. This is the main advantage if you use IO1 and IO2. Okay, some enterprise application requires multi-servers to access the same shared storage simultaneously. Okay, so instead of creating the separate EBS volume for each server, we can attach the same EBS volume to multiple servers. So this is the small information about the EBS volume types. So when it comes to overview, so this is everything I have tabled. So features are like GP3, GP2, IO1, IO2, ST1, SC1, magnetic one. So storage type is SSD, IO1 is SSD, IO2 also SSD, and remaining 3 are HDD. So these are the some features I have documented. Okay, so generation and best for multi-attached. If you see, only IO1 and IO2 only supporting for the multi-attached. Remaining, it will not. So encryptions we will see in the KMS sessions. Cost, common usages, everything we have discussed already. So this is the overview about EBS value types. Let's discuss about snapshots. Snapshots are backup of EBS value at that particular moment. So for example, whatever the data is present till now in the EBS value, whenever there is an activity, you can take the backup of that particular data using the snapshots. Okay, so snapshots can be used to restore the data. We can also create the new EBS volumes, and also we can create the custom AMIs. So it is very useful when data backup we have. So these are the advantages we have whenever the disaster recovery happens. So we have the backups and easy for the restoration. And if you want to copy the same data to other AWS regions, we can also do that using the snapshots. We can also do the volume cloning. So with the same data, we can create the another new EBS value using these snapshots. Let's see in the practically. So these are the my EBS values which are existing and attached to the instance. We can take the snapshot by selecting the any one of the EBS value. Now create the snapshot. Let's see, before that, let's see what are the snapshots available. As of now, I don't have any snapshot in the Northern Virginia region. So go to the volumes, select it, create the snapshot, description, something we can give anything, backup, this volume ID. You can see we don't have any other options here. I'm creating a snapshot. So I'm taking the backup, whatever the data is present in particular, this value. Okay, so the same data is available in the snapshot. You can see in the snapshot section. We can see here. The snapshot status is still pending. Go inside the percentage, it will show here. So it will take some time to come available state. So like this, after some time, it came completed status. So like this, we can create the multiple snapshots for the EBS value. Okay. So using this snapshot, we can also create the values. So to create it, just select the EBS value, go to the actions. You can see create a value from the snapshot. Click here. I'm choosing this one, USist 1D, because my instance is present here. So that's why I'm choosing. So we can create the values here like this. And so storage also like volume type also we can select it. And if you want to increase the size, you can also increase. IOPS, if you want to need to modify, you can modify. Then I have chosen the 1D because my instance is present in 1D location. I'm going to attach to the existing server. Okay. So the volume is created. Go to the volume sections. So this is created. Now it is available state. Click on the action, attach the value. So my instance is present. So /dev/sdd is my device name. I'm attaching it. So if you go to the instance, it will show 4 EBS values. Earlier it is 3, now it is 4. Like this, we can create the multiple snapshots and we can attach, create the EBS values and can attach to EC2 instances. See how to detach the EBS values from the EC2 instance. To detach the EBS values from the server, we need to stop it. Means it requires downtime. Okay, so downtime means we are stopping the server. Whenever you are stopping the servers, we need to take the downtime, means we have to take the approval from the business end, means customers. So to detach it, select the server, go to the storage, choose whatever the EBS value you have to detach, select that one. So I'm selecting SDC because I'm not selecting the root device. Okay, select it, click on this, select, go to the actions, detach the value. So if you see, this value came to available state. Okay, it is not attached to any resource. If we want to delete, we can also delete. Just select the EBS value and delete the EBS value. Just confirm it. delete. Now we can also create the custom AMIs using snapshots. So select snapshot, create the snapshot, and we can give the image name, some test, description, anything. So architect, if you want to change it, you can change it. And root device SDA1, hardware disk, make it default one only. So if you want to change this, you can change it, and we can also create the images. So AMI is created. You can see the status once it is completed. So once it is completed or available state, we can choose we can launch the instance from these AMIs. Okay, the same data will be available in the server. And another advantage using this snapshot, we can copy the snapshot to another regions. For example, if your application is also present in another region, for example Mumbai region, so we required the same data. What is the present, what are the data present in the northern Virginia, so the same data should be available in the Mumbai region as well. So we need to copy the snapshot. So to do that, select the snapshot and copy the snapshot, select the region AP Southeast one. I think AP Southeast one is the correct one. Yeah, AP South one. And you can copy. So snapshot is copied to AP Southeast one. You can go to there. Oh, sorry, AP Southeast one is there. Singapore region. That's okay, fine. It is copied to Singapore region. Okay, so once it is completed, we can create the EBS volumes in this region, and we can attach to instances what are the present in this region. So like this, snapshots are very useful as a backup. Thank you guys. If you really like this video, kindly subscribe. Thank you so much. See you in the next session.